Hi, this video will discuss the substitutability of inputs, along with present the marginal rate of technical substitution, abbreviated as MRTS, explain what it is. So the left side of this image you're making bags of potato chips. And you have 1 bag of potato chips, 2 bags of potato chips, and 3 bags of potato chips. These are different isoquants to make 1, 2, and 3 bags of potato chips. And note how easily you can substitute Maine potatoes for Idaho potatoes to get you those potato chips ingredients. On the right side, these are boxes filled with Cheerios. And to make a box filled with Cheerios, you need both the physical cardboard box. That's what the vertical axis represents, cardboard boxes. And then these are the ingredients that fill the cardboard boxes, the little Cheerios. So Cheerios are on the horizontal. And in this image, how substitutable are Cheerios for cardboard boxes to make a box of Cheerios? They're not substitutable at all. You need a given number of cardboard boxes and a given number of ingredients to put in the cardboard boxes to fill them. So look, if you have enough ingredients to make a single box of Cheerios and you have many more cardboard boxes than you have ingredients to make 1 box of Cheerios, the additional cardboard boxes don't help you any. Likewise, if you only have a single cardboard box, but you have many more Cheerios than can fill a single box, this doesn't increase your output either. So you need the perfect combination of cardboard boxes to go along with the ingredients. So the expansion path here is on a 45-degree line, the most efficient expansion path. This way you don't have leftover cardboard boxes or you don't have leftover ingredients. So these are not substitutable at all. These are perfectly substitutable. So your typical, though, isoquant is this one in pink. It's somewhere in between the case of perfectly substitutable, the line, like the potato case, or the Cheerios in the Cheerio boxes case where they're not substitutable at all. So the typical isoquant is in between those two, has a downward slope and a smooth slope. So let's now introduce a new term called marginal rate of technical substitution. What is it? This is the rate you can swap out one input, capital, can be exchanged for another input, labor, without changing output at all. So on this isoquant, your output was 1 everywhere along this combinations of labor and capital that got you 1 unit of output. So that's what MRTS tells us. The ability you're able to change out capital for changing in labor to get your marginal rate of technical substitution. Let's show this on a graph. This is also the slope of your isoquant in absolute terms, because your isoquant always has a negative slope. So here is an output, different ways you can get 10 units of output. Capital on the vertical, labor on the horizontal. And suppose you start out here at point A, and you move to point B. And moving to point B, what has happened? You have given up 6 machines. Well, you better get something in return to help you make your 10 units of output. And we're going to give you an additional worker, going from 2 to 3. Okay? So getting an additional worker, you had 2, now you have 3 workers, giving up 6 machines, a reduction of 6 change in K, you're still on the same isoquant. What this means is your worker, 1 worker, is as productive as giving up 6 machines. So your marginal product of labor is 6 times the marginal product of capital at point A. But note, you're not willing to continue swapping 6 for 1. Now, to stay on the same isoquant, you're willing to give up 3 machines in exchange for 1 more worker, and you get the same units of output. You're on the same isoquant. So now, who's more productive? Well, workers are still more productive than machines. Workers are actually 3 times as productive as machines at point B. In a similar fashion, the MRTS continues to decline as you add more and more workers, until you're at point D, where it's a 1-for-1 exchange. So let's show this now using some algebra. Your isoquant you're still producing the same level of output, so your isoquant change is 0. So what you're doing is you're changing your inputs. You multiply your inputs by that corresponding marginal productivity to get you a 0 change in output. So this is, of course, the additional output from one more worker. This is the additional workers you have, additional output from another unit of capital, and additional units of capital that you have. So let's rearrange these and get MPK and change in K on the right side. So subtract both sides by that. And finally, let's group our marginal productivities together. Okay? So grouping our marginal productivities together, now we just do some rearranging. We get this ratio of MPL over MPK. This is the change in capital over the change in labor gets us the marginal rate of technical substitution. So recall that very first point where in this equation we were at point A. We're willing to give up 6 machines to get one more worker to keep us on the same output, same isoquant. So this told us that the marginal productivity of labor was 6 times the marginal productivity capital. So the MRTS right here is 6. That's what this equation says. MRTS is 6. That's because the marginal productivity of labor was 6 times the marginal productivity of capital, or you're willing to give up 6 pieces of capital and in turn get one more worker to get you on the same isoquant. That's why the MRTS there is 6. And this is this ratio of marginal product to labor to marginal product to capital that gets you 6.